Hey, we got some video today. You are now tuned into the network,
Bruh.
the YouTube channel that takes complex networking topics and dumbs it down on more simple language. Today we are doing EIGRP today. Uh, I'm actually using hardware today, so we're not using a network simulator. For the last couple days, last couple streams, we've been using Boson NetSim, and I decided to fire up my terminal server and my routers and a switch. This is the network topology we're going to be working with. Let me see if I can pull it up over here for y'all. I think I gotta actually a drawing. Hold on, let me see. It's in my documents folder here. No, it's under pictures. E. Where's the E's? There you go, right over there. Capture number. Could have sworn it was in here. There you go. I'm like, what's going on here, man? This is the network topology we're gonna be working with today, right? We got we got three routers and a switch in the middle right there. I believe we're going to put all of these guys in the EIGRP. Y'all let me know if y'all can hear me. And let's see. Yep. That's pretty much what we're working with. So router 1 over here on the left hand side at the bottom, router 2 at the top. Make this a little bit thicker so you can see. Router 3 right there, and then this guy is just the layer 2 switch. He's just acting as a hub in VLAN 1. I don't think I do any kind of configuring on the switch right there. So I already kind of did the IP address thing, so we can get right into it. All I really need to do right now at this point is just verify the the IP addressing, I guess, and stuff like that. So while we wait for some people to tune in, I'm kind of verify all of that stuff there, right? Show IP interface brief. Show IP interface brief. And
You stupid.
nah, man, I just got to that guy's up down for some reason. See what's going on here, and I'm glad we did this before we actually got started. Router 1 has a FA01 101011. What is going on here? 101011. Oh, you know what? I think that was a interface that was already on there, so I don't need to worry about that. I just need to kind of remove that. So interface FA0/1, and we'll just get rid of that configuration. No IP address. And now we'll run a show IP interface brief. Take a look. Feels good to be right back in the no, you know what? That needed to be on there because that goes to switch, I believe. No, why is it up down though? That's my question. Router 1. Let's see what router 1 is. He has one interface there, serial. That one that should be going to the switch, and then the loop back, right? That's router 1. The serial interface is not even up. So that's probably what's going on here. Let's take a look. I'm going to go to router 1 and take a look. So it looks like I got some cabling stuff I got to do here. Y'all bear with me here. I'll be forgetting where I move these monitors over here, man. We got Foster in the building. Appreciate you tuning in. Said, bro, loud and clear. We got Caden Collins in the building. Appreciate you for tuning in. You get 3 horns. He said, sound is good to go. Appreciate the sound check. I got to check the cabling, though. So let me see what's going on with router 1. I have, let me see. The loopback, obviously, that's a virtual, that interface. That should be correct. 10111. This should be 10101. The FA00 interface. Well, my interfaces are going to be different, so I'm going to see. FA00 10101. That's correct, and it's up, and it goes to the switch, and then the serial interface, which should be 10121, which is what I just erased, wasn't it? No, 10101. Yeah, that's correct. And then the serial interface should be 10201. What did I just erase though? that right there, 10.1.200.1. That's interesting. Let me take a look at the serial interfaces and get back with y'all. Hold on. That's not good. Y'all should have seen what happened. I got a fluorescent light that just fell down, but it didn't break. So it has a metal like backing part. I just had it standing up and it fell down. But anyway, the lab calls us to configure that interface later anyway. So I think I'm gonna just leave that for now. Let me see. Yeah, it calls us for it to configure it later because that's what it says in the book. Let me see what it says. Let me see what it says because I remember seeing that somewhere in here. Leave the switch in its default blank configuration. By default, all switch ports are on VLAN 1. Yeah, for now, also leave the serial interfaces in their default configuration. You will configure the serial link between router 1 and router 2 in step 4. Router 1 and router 2. So we're going to configure this later. So that's probably why. No, it's not up down. The FA00 interface, FA01 interface is up down. I want to take a look at that. I'm going to take a look at that real quick. I just want to see why is that up down. I should have been looking at this. He said, so heard that. Yeah. I don't know why that one is up down. Let me take a look at that real quick on router 1 also. Also, I need to make sure that these are labeled correctly too. That's the thing about when you're using hardware instead of just like GNS3 or even G or something like that. You don't have to worry about all this. But y'all know I like tinkering with hardware and stuff. So yeah, it is an 1841. So that's all correct. And the loopback, yeah, it's down, down. It should have at least, I believe, no, it's not gonna come up until I think I configure it. But I would have at least seen it to come up. Let me see. Let me just look at I just want to see show run interface serial. I should have done this before the stream though. Yeah, there's no IP addressing on there. There is an IPv6 address, I guess, from probably a previous configuration, and then 010. He has no IP address either. Yeah, that's probably like from a lab that I did a long time ago. But there's no, it's not shut down or anything. So I don't know. Either way, let me look. I want to see what that FA0 interface is, and then we're gonna get started. Hold on. One has an FA00 interface that goes to the switch. That's what it is. I don't even know what the heck that is or why it's even up down. Anyway, this one is the one that goes to the switch. That's this interface right here, FA00. Anyway, he said, where is the FA01 in the topology? Let me see. Yeah, that's a good question. This right here. That's exactly what I'm trying to figure out. I don't even know why it's up down. There's not even anything connected to it. I would have thought, yeah, maybe because it's. Let me see. Let me look at the configuration for that real quick. FA0/1. Good question there. There's no IP address or anything on it, and Let me just look real quick. This is like Ghost in the Machine here. Yeah, it's not even. That's crazy. I would have thought it was down, down. Not necessarily admin down, but just like down, 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 down. Um, it is. There's no light or anything on there, so I don't even know why it's even showing up down. So that's weird right there. Let me run that one more time. Show IP. Where you at? Yeah, interface brief. I'm over here struggling with the damn just regular configuration here. All right, so yeah, that's down. And then router 2 has, let's take a look at him real quick, and then we'll move on with the lab. Show IP interface brief. Y'all know typically I will get started with some sort of news. We have the gig 00 interface. Again, my interfaces are different. And this is my terminal server set up right here. Where's that? Gig 00 interface set on router 2. So this is actually gig 00 right there. That's the one that's going to the switch. And then the serial interface we did not configure yet because they told me to do that later. Where is he at? He ain't even. You know what? That's what it was. I just plugged up the WIC card to it, rebooted it, and I don't even see it on here. So that's going to be a tough one. Well, I might have to even skip that part. Let's see. So how would I be able to put them in EIGRP? So you know what? I might have an EIGRP neighbor, but might not be able to even do this part right here because the serial cable is there's something with that WIC card that's not even showing up. This is why I need to start going back to the virtual labs, man. Fuck the hardware shit, man. Excuse my language. Let's see. Anyway. North Korean hackers are now using a new version of the D-Track backdoor to attack organizations in Europe and Latin America. That's rather interesting.
FBI, open up!
D-Track, I had to look what that is. Y'all know what D-Track is? Yeah, I didn't either.
You stupid.
Apparently, D-Track it's a remote administration tool developed by the Lazarus Group. So it's like some sort of malware. Its core functionality includes operations to upload a file to a victim's computer, download a file from the victim's computer, dump disk volume data, persistence, and more. A variant of D-Track was found on the Kundakulam nuclear power plant, which was used for targeted attack. So it's like basically type of malware. But anyways, North Korean hackers used it on I guess to attack some organizations in Europe and Latin America. It's a modular backdoor featuring a keylogger, a screenshot snapper, a browser history retriever, a running processor snooper, an IP address, and network connection information snatcher, and more. So it's like a whole bunch of tools for hacking, right? Apart from spying, it can also run commands to perform file operations, fetch additional payloads, steal files and data, and execute processes on the compromised device. The new malware version doesn't feature many functional or code changes compared to samples analyzed in the past, but is now deployed far more widely. So they didn't really do no updates to it or anything like that. They just came out with a new version, and I guess it's more easily accessible. A wider distribution, as Kaspersky explained. Y'all know Kaspersky, right? That's like they're like a security IT company. They do like investigations on these like malwares and all these breaches and stuff like that. Um, as Kaspersky explains in a report published today, their telemetry shows D-Track activity in Germany, Brazil, India, Italy, all these other countries they just go name it on. The targeted sectors include government research centers, policy institutes, chemical manufacturers, IT service providers, telecommunication providers, utility services, lions and tigers and bears, oh my. Y'all know I had to use my little built-in sound effect that time right there. In the new campaign, Kaspersky has seen D-Track distributed using file names commonly associated with legitimate executables. For example, one sample they shared is distributed under the nvcontainer.exe file name, which is the same name as a legitimate NVIDIA file. Y'all know NVIDIA. That's like the graphics card company, the company that come up with the graphics card. So I guess when they distributed it has the same file name as the executable that's used with that graphics card. So you thinking you about to upgrade your graphics card or launch the application that runs with the graphics card, but you're really running this malware. So y'all know these hackers be coming up with sneaky ways to get the malware onto your PC. So they go on and on about this D-Track software, and yeah, I guess it's more accessible now. So it's nothing new. It's just like I said, they just came out with a new version, and now it's easily more accessible. In February 2020, Dragos linked D-Track to a North Korean threat group, Wassenite, which attacked nuclear energy and oil and gas facilities. So y'all know they going ham with that malware. Anyway, y'all make sure y'all hit that like button and that subscribe button. Let's go ahead and get started with this lab here. We were still doing the cabling and stuff, right? Let's see. So we did router 2, right? We're not touching this until step 4. I'm gonna have to mess with the WIC card and see, or I might just have to skip that step. This is already configured. The loopback 10.1.2.1 is already configured. Yes, he is, and he is up. What else do we need to know? Marketing. I guess we do the VLANs, or is that the host name? What they came up with that for? Why they call it marketing? Is that a VLAN or what? What is that? Let me look at the sheets here. Oh, they just it's just an arbitrary description, so it ain't really nothing. Leave the switch in its default configuration. Yeah, they said leave the serial interfaces in their default configuration. You will configure the serial link between router 1 and router 2 in step 4. Verify that the line protocol of each line interface is up. You can successfully ping across each link. You should see output similar to the following on each router. So yeah, the loopback and the FA00 interface should be up. Basically, is what they want, which I think that's what we got so far. Loopback and the FA0 interface. So we got loopback, FA is up. Loopback, FA's up, and router 3, we didn't check him yet, right? No, we didn't. Show IP interface brief. Loopback and the FA's up. So we good to go there. I guess they want us to ping across. Let's at least try to ping. Let's have router 1 see if he can ping router 3. Does he even have a route? That's my question. Show IP interface brief. He's directly connected, so I don't see why not, right? My bad. Router 1. Let's have him ping that guy. Or he should be able to ping. Yeah. He should at least be able to ping directly connected neighbor, right? Ping. Because I don't think he'll be able to ping the virtual interfaces, right? He does not have a reply. Oh, yeah, he do. I was about to say. I guess router 2, let's just have him ping router 3 as well. That same interface. This guy right here. Router 2, ping. We got a reply.
Boom.
Okay, so 80%. All right, so we good to go there. What else we got left? Configure EIGRP on the Ethernet network. After you have implemented your addressing scheme, create an EIGRP autonomous system on router 1 using the following commands in global configuration. So same thing we've been doing all day, or all week rather. It's only Tuesday. On both on NetSend, but this time we're doing it on the actual hardware. So let's go to start off with router 1. They said put it in the 10 network. So go to global config mode, router, EIGRP, 1 network. They said just the 10 network. So basically everything in the 10 network. Let me see what we're doing. I think we're just going to be putting this pretty much network right here into EIGRP. That right there, that right there, that right there. I think that's what we're going to do because we're putting it in the 10 network. And the only thing that they have common in the 10 network is the 10.1, right? Well, they also have this too. So either way, it should put everything in EIGRP. So 10.0.0.0. They said no auto summary, so don't auto summarize anything. Same thing with router. Well, let me see. Before I move on, using network statements, blah 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 blah, which we already know. To check, okay. this is what they want us to see. They want us to debug the IP packets. Y'all remember how many EIGRP packets there are? And can you name them? If so, can you put it in the chat? Where is? I beg y'all. I should fix that right up there. This is the next one. Yesterday I gave y'all a video that I did like 3 years ago on what the EIGRP packets are. I also have a short that I talked about some other ones that are not really talked about very often. Let me see, because they came out with a new version of iOS that kind of resolves this issue. Gavin F. You know what? That's a tricky question. Now that you said 6, now that you said 6, that's a tricky question. So the ones that we really focus on, there's 5 that we really focus on, right? There's the query, where we're asking for some EIGRP routes. There's the reply, when they respond with, oh, here goes some EIGRP routes. There's the hello packet that we send every, I believe, every 5 seconds by default, right? And then we consider the neighbor dead at 10 seconds. So hello, query, reply. There's also the update. So like if let's say we got a route that goes down, we send an update to some other routers, some EIGRP routers. So hello, query, reply, update. And then there's also acknowledgement, the acknowledgement. So there's 5 EIGRP packet types. But technically, there's more than that, right? There's also the SIA query and reply, which is stuck inactive. So there's SIA query and reply. So that technically, that means now we're up to 7 EIGRP packet types. And then there's also, what else? Let me see. I said there are 7. Oh, here's one that I didn't really know about. Actually, there's 2 more. 3 more. There's the IPXAP, which I don't even know what that is, so I'm gonna have to Google that one. There's also the probe EIGRP packet type, and also the stub packet type, EIGRP packet types. Let me put it, they want us to put it in debug mode so that way we can see some of these packets flying around like we did yesterday, right? How do we do that? We just do, let's go to router 1 and do it though. We say, since we turned on EIGRP over here, debug EIGRP packets. Once we do that, we turn it on, and there they go right there. See, update, request, query, reply, hello. There's also this one that I didn't really know about, IPXAP, probe, I said acknowledgement, and there's also stub. And then there's the query and reply that I mentioned earlier. And here's the ones that they flying up and down right now, right? They coming back and forth. We saying hello every 5 seconds. So that's all you seeing right now, right? Hello, hello. He just saying hello. And nobody responded right now because why? He's the only one. This guy right here, he's saying hello to these guys, but nobody's responding. Why? Because he's the only one that's in EIGRP right now. So they just kind of like, hello, 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 and that's what's going on right now. We did receive a hello though, coincidentally. Which is weird. But let's turn on EIGRP on the other ones, and then we'll see. The hello packets are unanswered by the other routers because EIGRP is not running yet on router 2 and router 3, just like I mentioned. Router 1 ignores the hello packets from itself on loopback 1, so that's what's going on here. He's got hello packets from himself, so I guess he's pretty much talking to himself right now, man.
You stupid.
Use the undebug all command to stop the debug output. Y'all know that, right? This kind of turns this shit off right here because this shit gets kind of annoying. So undebug all. You could also just do u all and it turns it off, right? Use the show IP EIGRP interfaces command to display the interfaces that are participating in EIGRP, which we did that yesterday as well in the Boson NetSim lab. Show IP EIGRP interfaces. This tells us which interfaces are participating in EIGRP. FA00 and loopback 1. Where is he at? This interface and the virtual interface are participating in EIGRP. So I'm saying hello out of this packet, out of that loopback, and hello over here. And nobody's responding right now, right? What else they want us to do? Which interfaces are involved in the EIGRP routing process on this router? Well, I just said that. To monitor EIGRP adjacency forming between routers 1 and router 2 in real time while you configure router 2, issue the debug IP packets command. Yeah, no, I want to do this, but there's something with my serial cable that might not work for this. So I don't know. Let me see. In global configuration mode on router 2, so they want us to go to router 2, turn on EIGRP debugging. So debug EIGRP packets. So he's probably not going to have nothing. Why is that? Because we didn't turn on EIGRP. And he's not even saying hello. He's just standing there, right? Like a dummy.
Nope.
Let's see. Use the same set of commands that you issued on router 1 to create the EIGRP AS1 to advertise the 10 network. You should see debug output like we did in the other router. So we're doing the same thing, but we're going to turn on EIGRP, right? So global config mode. As a matter of fact, we should see router 1 and router 2 become neighbors. These two guys should become EIGRP neighbors, right? Go to global config mode. We said router EIGRP 1. That was 1, right? That was the AS number? Yes, 1. We said network 10 0.0.0, and then they became neighbors. Let's see. Do we become neighbors yet? It looks like, see, now we got all of this right here. Update, acknowledgement, all this shit right here. TID list, whatever the hell that is. Let me see. Did they become neighbors? And did they go right there? You see, EIGRP, new adjacency. So he's like, he finally, somebody said hello back to him, right? So he like, hello. Oh, hey, I got a neighbor. So that's why if we would have turned on EIGRP, the debugging back on, we would have seen all of this stuff that's flying on router 2. And that's what we would have seen right here, right? Let me Google that. Let's get a little deeper and see what that is, right? I don't know what a TID list. Anybody know what a TID list is? Because I really don't. Let's see. EIGRP. Let's see what that is. TID list type. Hello, can anyone? This is a forum I'm looking up in here. I think it's a TLV. How many searches in Google? Let's see. Got any questions? We got Professor Black Ops in the building with the Stigs of the day. Shout out to Professor Black Ops. He said, Stig managed network and management network are separate routing domains. Separate EIGRP or IGP routing instances must be configured on the router. One for the managed network and one for the management network. So we gotta have separate routing instances. Believe it or not, we can run more than one EIGRP, more than one EIGRP routing process on a router. So shout out to Professor Black Ops for that one. We could have this. We set like for example, we set this AS right here in EIGRP 1, right? We could have let's say we had another interface over here and a router over here, and then they became neighbors. We can have another AS right here and put it, let's say like EIGRP 2 right there, and so on and so forth. So, and if you want to be STIGS compliant, you got to have 2 separate routing domains, or separate routing domains. One for the management network and one for the managed network. What was it? TID list that I was looking for? TID list. See, just trying to, y'all know I try to learn and teach at the same time. Topology identification list. Nobody couldn't really explain it. Oh, maybe this link can help. Thanks. The URL is not working. Okay, so the URL is not working, but the content is about EIGRP multi-topology. You can search in Google. Bitch, I did that. Let me see. Yeah, that link is not working. I just wanted to see. I just wanted to get a little deeper into what the heck that actually is. Not really necessary for the exam or anything like that, but y'all know I like to try to do a little deep dive. The debug output displays the hello, update, and ACK packets because EIGRP uses reliable transport protocol for update packets. You will see routers replying to update packets with the ACK packet. You can turn off debugging with you all, which we just did. Then they want us to do the same thing with router 3. So make him participate in EIGRP so that way he can say hello back and then maybe all become neighbors, right? Let's go to router 3. Let's turn off debugging here because this shit's getting annoying, right? You all. All right, we turned it off right over here. As you can see, go back to router 3. Go to global config mode, router, EIGRP 1, network 10.0.0.0. And then he got 2 adjacencies right there. We'll see show IP, EIGRP, neighbors. And yes, I actually have 2 1841 routers and a 1921 for anybody that's interested on what I'm actually running here. And then you see how he's got 2 neighbors there, router 3. Who are his 2 neighbors? It is obviously it's this guy, and we get all this shit out of the way. Right? This is from router 3's vantage point, right? He has an EIGRP neighbor over here and an EIGRP neighbor over there. And that's why we have 2 neighbors there. They're running on, he learned them on both the FA00 interfaces, right? See that? He learned them out of that interface right there. And I believe we're going to have to broadcast. No, that's already being broadcasted, the loopback interface. He also has another loopback interface right there. Do we have 2 loopback interfaces? Let me make sure. Show IP interface. Brief. He should have 1 and 15. No, he's got 3 and 15. For some reason, 15 is not on here yet. Maybe I got to do that later. We'll see. Verify the EIGRP configuration. When router 3 is configured, issue the show IP EIGRP neighbors command, which we just did. So I guess we are ahead of the game there.
Boom, bam, bop, bada bop, boom, pow.
In the output, the H column on the left lists the order in which the peering session was established with the specified neighbor. So if we look over here, we have the H right there, right? So we learned about this neighbor first, probably because he said hello first, or he had a lower IP address, who knows? Then we learned about him. Actually, it's the other way around. We learned about him first and then him. So we'd had a list of like, say, 20 EIGRP neighbors. We'll see in what order we learned them in with that H, which is the, what does the H column stand for? It says it right there. The H stands for handle. That's what I love about this stuff, which is an internal number used by the EIGRP implementation to refer to a particular neighbor. So we have these right here. These are router IDs. But we also have this H, which stands for the handle, right? In case the router IDs might not make sense to us. So that's another thing that we could use to reference it. Let's check the neighbors on the other routers. Router 2 should have 2 neighbors as well. He got a new adjacency right there, right? So we do show IP, EIGRP neighbors. And there he is. Check whether EIGRP routes are being exchanged between the routers using what? Show IP, EIGRP topology, which we did that yesterday in Boson. Show IP, EIGRP topology. And those are the neighbors and routes that we learned via EIGRP. We have what? The FD is what? The feasible distance, which is the distance, like the full distance. Remember, that's how I remember it. The FD, the F stands for full, but it's really stands for feasible distance. It's how far that route is to you, like the metric for it. That is the feasible distance. See, it's the same thing as that. And you'll see a brackets next to that successor route, right? Successor is the best route, right? Success. That's how I remember it. Success, best. It's the best route. That's the route that gets inserted into routing table. And it's the best route to that network, this network over here. And then we get there via this hop. You'll see 2 numbers in a set of parentheses, right? The first number is the feasible distance. The second number is the reported distance, right? And that's the interface to get there. What else they wanted us to know? You should see all the networks currently advertised by EIGRP on every router. I guess if y'all want to do that, we could do that. He has his neighbors again. Remember last time he had nobody because he was saying hello to himself right there. I ain't got one for that. You got to be fast with this, man. See, I got like a whole bunch of. I got to like flip through them and stuff like that.
1 minute, 37 seconds later.
You will explore the output of this command in the next lab. For now, verify that each loopback network exists in the EIGRP topology table. So we have the loopbacks that we configured, right? Let's do this. Let's make sure we have routes to all of the loopbacks, right? Show IP into. So let's do show IP route. Let's see. He learned. Nah, he didn't. Let's see. He should know. Let's say, for example, router 1 needs to know some routes. There's a couple loopbacks on router 3, right? Let's see. We got 10131. Do we have a network? I mean, a way to get there. 10113. Yes, we do. Oh, okay. I didn't even see that. That D right there. Those are the EIGRP routes right there. Come on, man. What's wrong with me?
Are you fucking stupid?
And then router 2 should have some EIGRP learned routes as well. IP interface. You show IP routes. My bad.
You stupid.
And then there goes that route right there. There's the other EIGRP routes. So that's pretty much a loopback, right? The 10113 network and the 10110 network, which lies off of what? 10111 is this right here. And then from router 3, did he get some learned routes? Show IP interface brief. My bad.
You stupid.
Show IP routes. I gotta understand, man, to look at the third monitor, get these damn sound effects and do all this shit at the same time. It's a lot to stream, man. And the cabling, I didn't even look at the serial interface yet. We have yet to get to that part. I might skip it, who knows. So yeah, we got some learned routes over there too. All right, good to go. Got any questions so far or anything? Let me know. There's a lot of smart people in the chat room. If I'm losing y'all or anything like that. Professor Black Ops with another fun fact for us. What he said? He said, management network would be for privileged accounts. Those workstations could use MFA, which is what? Multi-factor authentication, and static or reserved IP address to lock down what machine could use that subnet route of VLAN. Zero trust networks. Ah, interesting. So if we want to, I guess, like, for like the IT staff that want to manage the network and stuff like that, and we have our users in a separate routing domain, right, or a separate VLAN, right? We want to make sure we keep all of that stuff separate, and I think that's what we need to do to be STIX compliant. So shout out to Professor Black Ops for that one. Let me know if I'm explaining that right, Professor Black Ops. For any of you, you guys are really into cybersecurity and want your cybersecurity fix, y'all visit him for like the latest cybersecurity updates and stuff like that. The next thing they wanted us to do, so we checked we checked for those learned routes. That's good to go. Now they want to. This is what I was waiting on right here.
No, God!
Configure EIGRP on the router 1 and router 2 serial interfaces, which y'all know my serial interfaces. I think they're not working, so we're gonna see if we can get this working. Basically, this little red lightning bolt right here, right? I have a y'all know the serial interface. It's a really slower link, basically, and I actually went on eBay because when I was learning about all this stuff, right, I used Packet Tracer, which y'all know this is like it's a virtual application, so you're not really seeing like physical hardware and stuff like that. And I started buying it, and I wanted to learn it hands on, like I wanted to really actually learn this stuff, right? And then I never seen what a serial cable looks like. I like Googled it and stuff like that, but I wanted to see how the cable worked and everything like that. So I actually bought one on eBay for like $5 or something like that. And because I was like, this ain't telling me nothing, man. Just looking at that lightning bolt, that's not telling me. So I actually bought one. It's not really much. I don't remember. Yeah, they're still in production today. Most networks, but it's a slower link, right? That's slower than Ethernet or fast Ethernet, right? Obviously, but yeah, I bought one just to see how it looks like and stuff like that. The cable got to fit in one side. It'll fit both ways, right? But it won't work on one way. So you got to make sure that you fit it, you plug it in, but it's plugged in correctly. So, and right now I have it plugged into a WIC card that may or may not be operational. So that's why we might have to skip this part right here. And I just wanted to see. So anyways, your serial interfaces are in there. Maybe because I haven't configured them yet. Maybe that could be why. Your serial interfaces are still in their default configuration. Specify the interface addresses according to the diagram and set the clock rate to 64 kilobits per second for router 1. So we're going to go to router 1, right? And notice on the other thing too, when you're setting up a serial interface, one side is going to be, and I've explained this multiple times on this channel, one side is going to be the DCE side, or data communications equipment side. The other side is going to be the DTE side, which is the that's data communications equipment, and I believe that's data terminal equipment, right? This side is what's doing what's called clocking. I'll try to draw a clock for y'all. I guess this is my clock right there. Whatever. So he's going to be doing the clocking to this guy, and at 64 kilobits per second, right? That's slow as fuck. I know.
You stupid.
So I don't even have one for that one, but we need to set the clocking on router 1. They said so. Let's go to router 1. Maybe that could be why it's down, right? So show IP interface brief, and I didn't see any lights over there and stuff like that. Right now it is plugged into, I believe, serial 000. It's obviously it's down. So we're gonna go to global config mode. Serial 000. Oops, 0/0/0. And they said to give him an IP address of 10.1.200.1 subnet mask of /24, which is 255.255.255.0. No shut. Are we going to get a? Oh. Did we do the clocking on this rate? We didn't do the clocking. Clock rate 64 kilobits per second. Same thing we did in Boson NetSyn, but now we're actually using a serial link cable, right? We could also verify the, notice it's still probably going to be down. We didn't get any terminal messages there, so let's do a show IP interface brief again. We have it configured, but it's still showing down. Show controllers. This is another command I like to do to check on that. Show controllers serial 000. That lets me know if my cable is in there correctly. 0/ Come on, man. Shit. You deserve the
come on now, dog.
That's 0/
Come on, man.
So controllers serial. Once we see this right here, this lets us know, okay, we got the clock right there. As long as we see this right here, that lets us know the cabling is correct. Should be correct, right? I think so. I don't know. So, because if it's not, you'll see it looking like this: 0, 1, 0. If it's not in there correctly, it'll look like this: no serial. It says it right there in plain English: no serial cable attached.
You are so dumb. You are really dumb. For real.
So I think we put it in there correctly. So I think we're good there. Now they want us to go to router 2. And configure that interface. No shut it, right? So we did the clocking. We verified it right over here, and then we see it says DCE, so that lets us know we are doing the clocking, right? So we should be good to go on this side right here. So we configure that side. Now let's go to this side, set that interface, which should be 10.1.200.2, right? 10.1.200.2, right? Y'all see that? Make sure we did the other side correctly. 10.1.200.1 was that side, right? .1, right there, right? For anybody that's lost or anything, right? Router 2, right? Go to global config mode. Interface, what's wrong with me? Serial. Oh, see, he's not up. See, let's see. Router 2. Let me verify what interfaces I got there. Show IP interface brief. That's what it was. The serial cable is not showing up. And I have it plugged up to a WIC card. So let me think here. We might have to use the serial interface on router 3 just to kind of fudge this lab. We might have to fudge this lab right here, right? And just, let me see. Just want to see something real quick. We might have to just move that cable over here. That's probably what we might have to do. And then put this interface, that IP address. Where's that IP address? We might have to move over. We didn't configure it yet. We didn't configure it. My bad. On router 2, we might have to move. Where is it? The one that I just configured. I didn't configure it yet, did I? Router 2. No, router 1. We said 10 to 100, 10, 1, 200, 1, and then 100 dot. Let me see. No, that's not it. Let me see.
You are so dumb.
My bad.
You are really dumb. For real.
10, 1, 201. Yeah, so that one. 10, 1, 200. That's what I was looking for. My bad. So this was that configured. So we need to do 200.2. Yeah, 200.2. I got confused with this IP address over here. We might have to put that 200.2 on router 3. That's what I might have to do. So let me tinker with the WIC card and the serial interface just to see if I can get it up. If not, then we'll just fudge this lab and put it on router 3. So y'all give me a second over here, right? All right. So, oh, we got a broken pin. This might not even work. Let me show y'all real quick. I'm gonna show y'all. That's crazy. Show y'all real quick. I need to unplug it. All right. So here's another reason why I might have to go back to virtual labs and stuff like that, man. GNS3 or even G and all of that. So I have a broken pin. I don't know if y'all can see that or not. This may or may not work either way. So I'm gonna move it over to router 3, like I said, because the WIC card ain't even showing up on router 2. Router 2 should have had some serial interfaces. We got these these fast Ethernet interfaces that are showing up. And if I remember correctly, I think the card on there, that slot don't work or something. I don't remember. I'm gonna reboot it just to see. Who knows? But router 3, we're gonna move it over to router 3. We do have some serial interfaces there, so we might configure that to work. And then, oh, you know what? I have an extra serial cable. So, but anyways, for anybody that's interested, yes, I'm a nerd like that. You'll see that is the serial interface, right? There's a broken pin right over there. Y'all let me know if y'all can see that or not. But it's at the bottom, I believe. Let me see if I can, so that way y'all can see. I'm trying to move it so that way y'all can see it, right? But yeah, there's a broken pin somewhere there at the bottom. Is it on this side? No, it's at the top. It's at the top. When I hold it like this, you'll see the broken pin. So this one may not work. So I'm gonna swap cables. I do have another cable. I'm gonna put it on router 3. And then we're gonna try to get that going. So we're gonna make this work. Router 3. Up. You may or may not have a light come up. Router 3. Yes, on slot 0. This might be better. All right. Coming right back. Appreciate you guys for rocking with me. All right, so we're gonna do what we were supposed to do on router 2. We're gonna do that on router 3 instead. So in other words, this cable right here that y'all see, this link, we're just gonna make sure we're gonna plug it kind of like, it's gonna be like this. The cable's going over there instead. right? So we're just kind of fudging up this lab here. Not fudging it up. We're just customizing it. So go to global config mode. Actually, let's make sure that the cable is showing up first, right? How do we do that? Show controllers serial 000. Again, do we have the cable? Yep, the cable is attached. Perfect. And I'm using the cable that doesn't have the broken pin. Now we're going to go to router 3. Go to global config mode. Which interface did I plug it into? I believe it was serial 000. So I'm going to go to interface serial 000. Give him the IP address of, what was the interface they said? It was 10.1. I'm going to go ahead and copy it. That's router 3. 10.1.202. Then they said to no shut it. Get rid of this. No, man.
You stupid.
Copy over here. See if we can get this going. Press enter. No shut. Snow shut. And let's see. Wait for it. Wait for it. Let's take a look. Let me make sure that is the correct interface too. Serial. I might have to go back and take a look again and see if I plugged up into the right one. Router 3's serial 000 interface. Let's see what we got. Show controllers. And it could be that the cable might be plugged in wrong because, again, the serial cable, you can actually plug it in like this both ways and it'll still fit. But it only works one way. It has to work with the, depending on what cable you have. It has to say the label at the top. So serial 0/0/0. Let's see what we got here. No serial cable is attached. Let's take a look at the other interface, which was 010. So I've got it in 010. Y'all see that?
You stupid.
Let me triple check that. Let's see. All experiences. I see why they did that. I think I see why they did that. All right. I don't know. They both say slot 0, so they both say slot 0. So just the slot numbers are different, I guess. But they both said slot 0 on the same exact side, so that's why I would have thought it would have said serial 000, but apparently not. So that's probably the one we have to configure. Let's put 000 back in its default config. Get rid of all of this. Come on, man. This thing is taking forever.
Come on now, dog. Come on, man.
Brief. Let's see. Brief. And then we're going to take that interface. Where is it? We're going to take that IP address and put it on this one over here, right? So let's go to global config mode. And we're going to default interface serial 0/0/0. Right? And then we're going to go to interface serial 0/1/0. Oops. 0/1/0. Give him that IP address. Oops, my bad. That's not what I meant to do. Copy and put that IP address on this guy. No shut him. Snow shut him. And we have the cable. I mean, theoretically, this should work, but I don't know what. This is the thing about hardware, man. We did the clocking on this side. Let's see. What do we have? We might have to flip it around. Oh, he's doing clocking too. We need to get rid of that. That's probably what it is. Let's show run interface serial 0/1/0. Yeah, let's get rid of that. We should not have clocking on both sides. That's one thing we need to be cognizant of. 0/1/0. No clock rate. That is that gonna bring it up? We have a IP address over there and everything. Show IP interface brief. He's still not coming up. Come on. He got a TFTP there. 10.1.202. Come on, serial interface. We might have to go over there and flip it over, but it did recognize the cable, so I don't know why he's not coming up. If anybody want to give me some pointers here or why they think it's not coming up. Jason Whiting in the building. Appreciate you for tuning in. He said, how do you make the line command with different colors? It is a file called Cisco Words with Backgrounds or Cisco Words or something like that. If you, let me see. So with this application called Secure CRT, its default, the colors will be just black and white, or I believe it's like white and black, the other way around, right? But there's a file that you can download, and it'll customize it for you like this. If you just do Cisco Words with black background or something like that, you Google that, you'll see there's a file that Secure CRT. I think they have it in their forum, and then you can get those colors and stuff like that. It's pretty cool, right? That's why I love Secure CRT. Show IP interface brief. He's still not coming up. Show, run. Let's look at the controllers again. Show controllers. I'm gonna flip that cable around one more time and see if that makes a difference. And if not, then I might just skip this part, man. And be fudging around with a damn serial cable, man. It's ridiculous, man. We still have the clock rate in there. Why is that? Why is that? Let's see. Show run interface serial. Oops, interface serial 0/1/0. The clock rate is still in there. Maybe that's a default thing. You know what? I think I remember seeing this before.
No, God!
We have clocking on both sides, right? Let's see. Because he's clocking at that rate. Let me look at serial interface on the other side real quick. Interface serial 0/0/0. Let's see what we got here. I don't know what the heck all this is. Do we need to get rid of that? I don't know. Serial 0/0/0/0. No, that. No, fair cue. No. I don't think that has anything to do with it. I think that's probably like quality of service or something. But he's not coming up. So, anybody have any pointers or what they think will bring this serial link up? I'm not quizzing y'all. I really can't get this cable working here. So, and I think this is a good cable. I don't think there's any broken pins on this one. As a matter of fact, y'all seen it recognized it, right? It says it right there on the router 3 side, and then the other side was router 1, right? So we checked it on this side, checked it on that side. Don't ignore this part right here. It's actually serial interfaces, right? Let me do it one more time with the controllers, and then I'm gonna go over there and flip it. And if that don't work, 0/0/0. He says clock rate of that, DCE of this. Same thing on this side, right? Yeah, that's what we got on that side. Yep. I don't think you can get rid of that now that I think about it. I think that's like the default clock rate. And y'all see we got rid of it, right? Show run interface serial 0/1/0. We supposed to be doing EIGRP. We over here messing with damn serial links over here. It's ridiculous.
Come on now, dog. Come on, man.
Interface serial. I'm gonna get rid of that. We did a default, right? Didn't we? No clock rate that, right? Didn't we do that as well? I'm gonna go on the other side, flip it over real quick, and then we might just pass that part. That's the right one. DCE, yep. One side is doing the clocking. DTE on this side. There you go. There you go.
Boom, bam, bop, bada bop, boom, pow. Pow.
And that's what I mean by that serial cable. It fits in both ways. You can put it in like this, and you can put it in, flip it over, put it in like this. But only one side is going to work. And as you can see, I sat there for like 5 minutes messing with that. Imagine you put both sides wrong. So you got to flip both of them and have the right combination. And then you see now the link is up. So we good to go here. Let's see. See, we got it on this side too. Let's do a show. I'm so excited over here, right? I can't even speak.
That was easy.
So we got over here. There's a serial interface. It's up right on this side. We should be able to ping what .2, right? Is what it is. Ping that .2. No, we didn't. Oh, you know what? I don't think he has a route to that side, do we? No, I don't think he has a route to that. I think is what it is. Oh, or did we even configure it? Yeah, we did. It's 10.1.200.2. He just don't have a route that way. This is what it is, I think. But it's directly connected, so that's weird. Let me see. Router 3. We do a show IP interface interface brief 10. Where's he at? Yeah, 10.1.200.2. No. What came up on this side? 0.000. Oh, you know what? There it is. So look, there was the correct interface that I did last time. Remember I said that? And I said, well, you know what? Maybe it's the other side. No, we had it in the correct. That was the correct serial interface. So that's what I did right there. Y'all see that now? And this is why I like cabling and mess with the hardware and stuff like that. It gets you to do all this troubleshooting you got to do here. So it gives us experience, right? And no, I work as a network engineer and stuff like that, but I'm not actually having to deal with serial. Like, I missed that part. That's like 20 years. This is like technology from like 10, 15 years ago and stuff like that. But it's good to have this experience under my belt. And then we'll be able to catch up with fast Ethernet and gigabit Ethernet and 40 gig and 10 gig, right? So serial, let's default that interface right there. Let's do that. We're going to default interface serial 0/1/0, and we go to interface serial 0/0/0, /0, and give him the IP address of that 255.255.255.0, and then that should be good. Now we got the EIGRP neighbor. Now we should be to ping across, and life is good, man. Ping, where's he at? There he is, right there. We got some replies. All right, so we good. Y'all see, and again, when you guys are messing with serial cables, I doubt you'll have to do this in the real world, because you'll still see serial links in production networks nowadays. But that is the issue with the serial cables. They fit both ways in the link in the port, right? But only one way will work. I had both labels pointing up, so apparently that's not how you got to do it. One has to be up, and I think the other one has to be down. I don't know. There's even a tag on the cable that says, make sure it's the correct way. So I think I remember a stream that I did a long time ago on this channel that I had this issue before too. So what's the next thing they wanted us to do here? The bandwidth is set primarily to provide the composite metric factor and a realistic and true description of the available bandwidth of an interface. It is also used to prevent EIGRP from flooding interface. By default, EIGRP uses up to 50% of the bandwidth that the interface reports to the Cisco iOS software. Suppose there was a significant routing instability in some other part of EIGRP AS. If EIGRP was to use 50% of the 1.5 kilobits per second for its own routing information traffic, EIGRP traffic would fully saturate the low bandwidth of the serial 64 kilobit serial link. So EIGRP uses a lot of bandwidth apparently, and we would pretty much flood this link that we have over here if we had some instability on this link right here. So if we had too much, because remember, we have all these hello packets that be coming across, right? Remember, we showed you earlier, we got all these hello packets, and then we have all these acknowledgments coming right back. We have all these updates coming right back. And we have all these replies coming right back. So all of this is using up all the bandwidth, right? But if we have some sort of instability, we'll have EIGRP packets flying all around, and it'll be all fucked up, right? So that's what they said with the clocking and stuff like that. The bandwidth is set we set the bandwidth when we do show interfaces serial 000. So we do. I'll show you real quick what we have it set to. Oops, I should have copied it over there. My bad. So that way y'all can see what they're referring to, and then we'll move on. I guess we're approaching an hour too, so we should wrap this up in a bit here. I'll be forgetting. I've been moving my monitor up here, and I moved the orientation. So
You are so dumb. You are really dumb. For real.
that's the bandwidth that they were referring to right there. What else they wanted us to do? Apply the bandwidth 64 command to the router 1 and router 2 serial interfaces. So no, router 1 and router 3 in our case, right? Because we changed it up. So interface serial, what is it? 00? Yeah. 0/0/0. They want us to put the bandwidth 64 command there. Same thing on router 3 interface. I love seeing that EIGRP adjacency right there. Bandwidth 64. We check again, we'll see show interface serial 000. We change the bandwidth to 64 kilobits per second. That's how we verify it. What else they wanted us to do? Show our neighbors, which I think we pretty much did last time already. On router 1 and router 2, they want us to show our EIGRP neighbors. All right, you want to play that game? Whatever. EIGRP neighbors. We got 3 neighbors, obviously. Right? Same thing on router 2. Show IP EIGRP neighbors. Y'all any questions or anything so far? Y'all hit me that like button and the subscribe button. We got Bucky Roush in the building. Appreciate you for tuning in. I ain't see you in a minute. He said, nice. It's been a while since I saw you stream again, bro. Yep, it's been a minute, man. Appreciate you for tuning in. You were one of my day ones over here. It's been a minute since I've been streaming, but I said I'm back into it. I moved into a new crib and stuff like that, and all my equipment, like I just had it sitting in the rack, and I haven't cabled it all up. I finally got my terminal server up again. Got my routers and switches. Well, I got one of them connected right now. I bought some Nexus switches. Yes, Nexus data center switches that I got for like $20 and $25. So I'm gonna be messing with that. What else did I get? I've been had firewalls. I had 2 ASA firewalls for a while. I got them like one of them for free. So y'all know I love tinkering with old hardware and stuff like that, which is still used today. So configure, but yeah, shout out to you, Bucky. On router 3, create loopback 1 with the interface. Create loopback 1, or actually loopback 11 with the IP address 192.168.100.1 and loopback 15. So basically, they want us to do this loopback interface and that loopback interface. That's what they want us to do here. So let's go ahead and do that. Let's go to router 3 and do that. Router 3 is over here. Go to global config mode. Let's go through this so we can get call it a night, right? Interface loopback 11. His IP address is 192.168.100.100.1 subnet mask of what is that? 30. I'm sorry. 250. When it's .252, the subnet mask is /30. It's a /30 subnet. I had to think about that. The next one was interface loopback 15. Oops. Back 15.
You stupid.
Come on, man. Oh, back 15 because I'm already in interface mode. IP address of he's 192.168.100.5 subnet mask of /30 as well. 52. Enter. Let's show IP interface brief to show our work. Verify, 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 right? No matter how simple the config is. He's that 1.5, but that does not show us the subnet mask. I believe it was show protocols that showed us, right? Was it show protocols? Yes, show protocols tells us the subnet mask, /30 and /30. I forgot who it was that showed me that command. I was like, wow, because that packet tracers doesn't have that. You know, you have to have actual iOS to run that command right there. But that's what I like, because see, show IP interface brief does give us a quick overview of our interfaces, but it does not give us a subnet mask. That's why I like show protocols. It gives us the line protocol, the layer 2 and layer 3, but it also gives us a subnet mask. So show protocols for anybody that's new. That's one command that you want to know. 9K. Oh man, I had an upgrade on those last week. That didn't go so well. Oh, that sucks, man. 9Ks. Wow, yeah. I bought some Nexus 5K switches, man. It was like this e-recycling company. It was like $20 and $25. And these are like, like they could easily go for like maybe $100 to $150 on the black market, but they don't know what they selling and shit like that. Do you use multi-layer 3 switches? Jason Whiting said, yes, I do. I have a 3750 version 2 that has PoE and stuff like that. I've got 3 of them. They're 24 ports switches. Configure network statement wildcard masks. Oh, we just did that. No, we did the loopbacks. And then they said, how can you add these networks right here that we just added, this network and that network, these 2 networks right here, to EIGRP without involving 100.4? Let's see. So we have 100.1 and 100.5. So they want us to add it without adding 100.4. Shout out to somebody who subscribed. I can't even see who it is. Oh, Raju Kumbar. Shout out to you for subscribing, man. Appreciate that. They want us to pretty much work with wildcard masks is what they're doing. When we do wildcard masks, we can specify exactly who we want to, what interfaces we want to participate in EIGRP or not. They kind of told us exactly how to do it with this. So on router 3, they said in step 2, you looked at how network statements select networks for routing by using major network boundaries, which was the 10 network. And that's how we was able to add everybody immediately, right? This right here. Let me show y'all real quick. We added all 3 of these guys in the EIGRP by just doing 10.0.0.0. That added everybody in EIGRP. Now they want us to be more specific and be more granular with the network statements, right? How do we do that? With wildcard masks. So we go with router 3. To do that, we're going to use a wildcard mask that is going to specify just that network, but not the .4, right? How do we do that? Go to global config mode. We go back to that routing process, EIGRP, not routing process, AS number, right? Network. As a matter of fact, they even told us 192.168.100.0 network. So that's going to add all of this. But if we just do .0 and just leave it like that, that's going to put every IP address or any interface that falls under this network address or network boundary into EIGRP. We might not want to do that, so we want to be more granular and pick specific addresses. How do we do that? With wildcard masks, which is the kind of like the inverse of a subnet mask. So in this case, 0.0.0.3. So we care about this for sure. In other words, the first 3, we want this to match. But this, we want just the first 200 and I believe the first 252 addresses, or is it the first, the opposite? The first 3 IP addresses, I believe, is what we're going to do with that one. So 192.168.1.2 and .3 will be added, but not .4 when we do it this way, I believe. Right? Y'all correct me if I'm wrong. So press enter. That should, we can verify it, I believe, with show IP EIGRP. Oh, interfaces. So did this solution work? Check with show IP EIGRP interfaces. See, I would have done show IP protocols, and that would have told me. So let's do. They wanted us to see what's participating in EIGRP, right? Show IP SIP, show
You stupid.
IP interfaces. Oh, my bad. Show IP EIGRP interfaces. That lets us know the FA00 interface. Was it interfaces? Let's see. Oh, and then they're going to want us to do a failover too. Hold on. EIGRP interfaces. Yes. So when we did that, that added loopback 11, which was what? This network statement into EIGRP. See, he didn't add loopback number 15 when we did that network statement. You see that? Even though the first 3 octets matched, we didn't add loopback 15. We only have these guys participating in EIGRP. The FA00 interface, which is the physical one, the loopback 3 that we had initially, this guy. So he's participating. Let me get rid of all this shit so y'all can see who's participating in EIGRP over here, right? That's participating in EIGRP. That's participating in EIGRP. 11 is participating in EIGRP, and this guy is not. So that's how we specify who we want. Maybe that could be like a specific, maybe that's a management network, maybe that's a DMZ that we might not want participating in EIGRP. Who knows? But that's how we can specify which interfaces. We could also do, I believe, named mode is where we're, like when we go to a specific interface and say, participate in the EIGRP AS number, blah, 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 blah. But wildcard mask is the tricky way to do it, right? It's easier to use what I think they call named mode. Bucky Rouse said, he said, we still have some of those as well. I should look into that. Yeah, 5K is really, if you're talking about the 5K switches, or are you talking about the 3750s? Those are really old, man. I was working at a hospital system like 2 years ago. We were doing an EOL project and replacing those with 9300s. So I hope you're not talking about the 3750s. Those are really old switches, but they're good for like, for home labs and stuff like that because they do layer 2, layer 3, and they have PoE. They're dumb cheap. So, what else? Yeah, it's a pretty good switch. Secondhand, at least. They're workhorses. What else were we wanting to do here? Show IP protocols. Yes, that's exactly what I was gonna do. See, so great minds think alike. Whoever authored this lab manual here, show IP protocols, also tells us who's participating. Excuse me. Who's participating in EIGRP? Really, it tells us what networks we're advertising for, which in this case is the 10330 network. Oh no, that's OSPF. What am I doing? 10 network, which is what we initially did, and then the 192.168 1.0 network /30. See, it says /30, but we did the reverse of that, which was the wildcard mask, which is the wildcard mask, which is 0.0.0.3, which is the same thing as 252 or 255.252, the inverse of that, right? That's what that is, and that's how come we was able to specify exactly who we want to be participating in EIGRP. What else they wanted us to do? So we did show IP protocols. They wanted us to do a topology change. Issue the show IP route on router 2 and router 3. Right? So we'll do show IP route. See the best routes, right? Show IP routes. Does he have a route to those loopbacks or whatever? I believe so. I think he just learned about it right over here. Yep. On router 3, they want us to do the same thing as well. We're almost done here, y'all. We're almost done here. Show IP routes. From router 3, trace the route to the loopback 1 interface. So from router 3, where's router 3? Trace the route to loopback 1. Right? Let me see. Let me show y'all real quick. So loopback 1 is over here. They want us from router 3 to trace that route. He's probably gonna go. Well, there's only one way to get there, right? Well, no, actually, he has 2 ways. He actually has. This don't exist, right? Because we moved that cable to over here. Because that shit right over here didn't work, right? We moved that cable over here. So now this guy got 2 ways to get to the loopback. He can go through the serial interface, or he can take the fast Ethernet interface. So he got 2 ways to get there. They want us to trace the route to get there. Trace route to 10.1.1.1.1, right? You see that? Trace route to that IP address, 10.1.1.1.1, right? Where's he at? Router 3, trace route 10.1, oops. Make sure I, .1.1.1. Hopefully we get a reply, right? We did get a reply. he took, I think, let me just ping that real quick because I don't even, the trace route be kind of tricky sometimes. 10.1.1.1. Yes, we got a reply, and make sure y'all hit that like button and that subscribe button if you're not subscribed to this channel, because they said 74% of my viewers are not even subscribed to this channel. Right? They say that's pretty average for the YouTuber nowadays. That 75% of the people just kind of like consume your content, but they don't even subscribe or support your channel and stuff like that. Just hit your boy with a like button and subscribe. That's all I'm asking for, man. I'm not asking for any donations or anything like that, or paying, or I'll give you a paywall or anything like that. You just pay me with the like button, man. What we needed to do. So we did get a reply. We took the next hop of 10.1.100.1. Where's that at? 10.1.100.1 is this interface right here. So the FA00 interface was, let me see what his interfaces are so I can get a clarification before I explain this. Brief. Oops, show IP interface.
You stupid.
Brief. No, it's just a ambiguous command, as you can see. The next hop was what again? 10.1.100.1, which was the 100.1, the FA00 interface. So it was that. So basically, yeah, this right here. So basically, he went this way for obvious reasons, because this is a slower link. He don't want to go that way. Because the serial interface was what? 10.1.200.1, right? Let me see. 10.1.200. Yeah. So if he would have took the serial interface, the next hop would have been 10.1.200.1. So that's what he did. He went this way instead of this way for obvious reasons, right? That's the serial link, right? So what they wanted us to do here, let's see. We did the trace route. Router 3 is using the next hop to the destination network, blah, blah, blah. From router 3, issue a ping with a high repeat count. You should see multiple exclamation points with the extended ping. And then they want us to shut down the FA00 interface on router 1. So, and then see which way he's going to get there. He'll still be able to get there though, right? Why? Because he got 2 ways to get there. So basically, this is what they want us to do here, right? Remember, we said we got 2 ways to get to this network. We got a serial link here. Right? We got that serial link, right? And he got 2 ways to get to that interface, to that network. He can go this way, or he can go this way. What they want us to do is, we're obviously going this way. What they're going to want us to do is shut down this interface. And then what's he going to do? He probably would be able to still get there going this way, obviously. Remember, this one don't exist because we moved the cable, right? Because that shit didn't work over there, right? So we ended up having to move the cable over here. So instead of going this way, he should be theoretically going that way, right? So let's run a high ping count with a repeat of, let's say what they did. They did 1,000, 10,000, right? And then we're going to shut that interface down and see which way he goes, right? Let's go over there. Go to global config mode and shut down the interface. What is that? FA, my bad, not the serial interface. The FA 0/0 interface, right? Do we have the ping still going? He's still going. Oh, we should have done more than that. Let's do it one more time. Let's add a 0. Let's add a 0 and see which way he go, right? We add a 0. We're doing like 100,000 pings right now, right?
No, God!
Shut that down and see what happens, right? We go to router 3. We waited.
1 minute, 37 seconds later.
Is he going to go another way? Come on now, EIGRP. It looks like that might be. There you go, right there. He picked back up. And then we lost a neighbor. It should say like goodbye received or something like that, right? Where is it at? I think it's on the other router. No, it just shows the EIGRP goes down. So it went down, right? Y'all see that? And that's what this signifies here. It went down, but guess what? EIGRP reconverged and said, okay, this way went down. We had a gopher chew that cable up, right? And then now we're going this way. That's pretty much what happened there, right? So I think that's all they wanted us to do here. Let's see. We did the extended ping. From the perspective of router 3, how many packets were dropped? Let's see. We could just look at the interface, the output once it's finished. But we could also just look at these dots right here and count them up, right? 1, 2, 3, I think at the end it tells you how many were dropped. That's probably too many pings we sent there, but once that stopped, typically you could just count those dots and see how many. But I'm sending too many pings right there, man.
You stupid.
But we're wrapping up this lab anyway. Which of the EIGRP timers causes this delay in the route recalculation? Does anybody know? I believe it is the hold timer. That's why there's a delay there. So it took a while. Like, we kept going that way, and we were sending hello packets. We like, oh, we don't have that route, and then we got a dead timer. Once that is expired, then we reconverged and went the other way. So we was sending hello packets going this way. It was like, hey, what's going on? Let's send some hellos. We got some replies like, we don't know how to get there. Oh, and then router 3 realizes, oh, you know what? I have a feasible successor. It's this way, which we should have checked the topology table to see that, right? We can bring it back up and probably see. Is this thing still going? Yeah, it is, man.
346 minutes later.
It's probably going to go at the end of this stream, but who knows? Who cares? Yeah, so I believe it's the EIGRP dead timer that causes that delay there. Use the trace route to find a new route, which I already explained which way it's going. Start the repeated ping again, and then bring the interface back up they want us to do. And then how many packets were dropped they wanted us to count. I'm not going to do all of that. Let me see. Let's see how long this takes. Actually, we can kill it. Let's kill it. Can we kill it? No, we can't. I think it's Control-Shift-6. Does anybody remember the command to kill this? I don't remember how to kill it, man.
No, God!
Control,
No,
Shift,
God,
X6
please,
or something
no,
like that.
no, no!
Let me see. I thought it tells you.
No!
Yeah. Anybody remember how to kill the extended ping there that you got? I thought it was Control Shift Z or 6. There you go, right there. Okay, so that's how many packets we dropped. 954 minus 946. What is that? That's 4 and 4. So we dropped 8 packets pretty much, but we got 99% complete right there. So then they want us to do the same thing, but bring it back up and then look at the pings. So we dropped 8 packets there. Yeah, so they want us to do the same thing, and then they said if you were using RIP version 2 as your routing protocol instead of EIGRP, would fewer or more packets be dropped? Anybody want to answer that question? I know the answer to that question, actually. If you were using RIP version 2 as your routing protocol instead of EIGRP, would fewer or more packets be dropped? Put it in the chat if you know the answer to that. Bars. Next spot here. Oh, congrats on that, Bucky. You've been doing big things over there, Bucky. If you don't know, it's actually more. Definitely more packets will be dropped because RIP version 2, I believe, sends updates every 30 seconds, I believe. So you would have to wait 30 seconds before you get a new route. And that's why it would be more packets dropped with RIP version 2. I actually have a video that I did probably like 2 or 3 years ago where I went on a rant on RIP version 2 and RIP NG and stuff like that. They make us learn about RIP and stuff like that, probably because it's the easier routing protocol to learn. But I have yet to see it used in a production network, and there's not really many benefits to using RIP for this particular reason right here. Y'all see, we only dropped 8 packets. We still got 99% success rate, even though the one link went down, right? Let's do the same thing and just send that many packets, bring it back up. Bring that interface back up. Bring that ass up. No shut. And see how many packets are we going to drop. If we do drop any packets. Let's see. I don't think we're going to drop any packets this time, are we? We no shut FA00, right? Let's see. Nope, don't look like it. So because we have 2 routes, and he's probably just going to change which way he gets there. We should get a neighbor too, shouldn't we? So it came back up. We shut it down. We brought it back up. Why isn't the we should have an EIGRP neighbor. There you go, right there. You see how long it took? See? Now look at router 3 again. We got a new adjacency, or router 1. We got a new adjacency. So now these guys are EIGRP neighbors again, right? These guys over here, these guys are EIGRP neighbors. And then 100% rate. See, we didn't drop any packets this time because why? Because this time he had 2 ways to get there. That way and this way, right? I think that's pretty much it, man. We're going to call it a night. I appreciate you guys for tuning in. Y'all make sure you hit that like button on the way out and the subscribe button. We're going to stream again tomorrow, either 8 o'clock or 9 o'clock. I typically stream Monday through Thursday. I've been doing at 9 p.m. because 9 p.m. seems to be a more ideal time for me. It gives me a little bit of time to regroup and at least prepare for the lab. Like today I had to do the cabling and stuff like that, get my terminal server up and running again. I told you I moved into a new crib and stuff like that. So I had to get my terminal server up and running again. I forgot how the settings were and stuff like that. So yeah, I'm glad we was able to get that lab up and running and see how EIGRP convergence works. We talked about the timers. We talked about the EIGRP packet types. We learned that there's more than 5. There's 5 that we really need to know for like the exam. It's update, hello, query, update, hello, query, acknowledgement, and reply. Those are the 5 ones that we really need to know for the exams and stuff like that. But there's actually about 8 or 9 EIGRP packet types, right? What are they? You will just do debug EIGRP packets, and there they are. If you guys want to take a screenshot of that right there. We got, let's see, 1, 2, 3, 4, 5, 6. Let me see, 7, 8, 9. There's about 10 of them right there. SAI query and replies also. So we got a whole bunch of EIGRP packet types right there. Anyways, for now, comment, like, subscribe to the network. Bruh. Oh, make sure y'all hit that join the Discord server. There's a link